All right, but let's keep going. We're going to do it the easy way. We're going to go ahead and use Excel to complete this problem. Okay, so next we've got our slope and intercept. This is going to be used for our linear regression and for making our prediction formula. So we're going to come back to slope and intercept in just a minute. We're going to go ahead and calculate our R value. We're going to go ahead and calculate our coefficient of determination, which is our R squared. And then the standard error, the estimate, or the standard error prediction, that kind of goes hand in hand with our linear regression and our prediction formula. So we're going to come back to this one also in just a little bit. All right, and of course over here we can go ahead and calculate our measures of central tendency, and we can go ahead and calculate a measure of variance, which is going to be the standard deviation. So let's actually go ahead and do that first. That's very simple. We've done that before in Excel, but let's go ahead and get that done using some Excel functions. So we're going to go ahead and insert function. For the mean, we're going to go ahead and select average, and again, if you don't see it, you can go to the statistical functions, and it's going to be usually the second one down. Here it is, average, and we're going to hit OK. We're going to go ahead and select this input box, and we're going to select all of our X values and put them in there and hit OK. Very good. So there is our mean or average X value. Let's do the same thing with the median. Let's go to insert function again. You can look if it's your most recently used. If it's not there, then of course you can type it in up here. Okay, you can type it in to look for it. And there it is. So we're going to select median. Very good. We're going to go ahead and input all of our X scores in and hit OK. And you can see what our median is. So that's kind of the 50th percentile, okay, right in the middle. That's our median body weight. Now, mode is there a most frequent score? Or is there a most frequent body weight? Let's go ahead and find out if there is. So again, we're going to go to insert function. Okay, we're going to be looking for mode, M-O-D-E, and hit go. And you notice that there's a couple different modes. Okay, there's an old one we used to use a long time ago, and there's multi if you have more than one. And we're going to go ahead and use this one. We're going to go ahead and use the multi. That's the one that we tend to use now. I used to use this one all the time, but let's go ahead and try using this one. We're going to hit OK. And we're going to select all of our X values and put them in there. And it looks like, and you can double check right down here. You can double check before you hit OK. And it looks like, yes, there only is one most common weight or X score, which is 182. This is the one that kind of occurs the most. So let's hit OK. The most common weight is 182 pounds. And then let's get our standard deviation. So we're going to go ahead and select this empty cell, insert function. We're going to go to let's see, standard dev, and see if anything pops up here. Nothing pops up. So let's go to statistics and let's just scroll down for it. And right here are our two standard deviation functions. We're going to go ahead and use the sample. Okay, this is standard deviation based on a sample. That is probably more correct to use in this example. So let's go ahead and use that one. We're going to hit OK and select all of our X values and put them in. Hit OK. And there is our standard deviation for body weights. Okay, let's go ahead and do the same thing over here for our Y values. So again, we did the mean, which is average, right there. Let's hit OK. Put all those values in. So I'm going to go a little bit quicker since we already kind of know how to do this, right? And then median, very good. We're going to go here. We're going to go to most frequently or most recently used. There's median. And of course, add all those data points in. Very good. And then mode, again, same thing. Let's go ahead and use our mode function right here. Hit OK. Put all of your Y values in. And again, double check. So right here, we have two. Okay, most common scores. We have a 37 and a 41. I always double check. This might be a multimodal array. So in this example, it is. There are two values that are the most frequent. So we have a 37 and a 41. So let's hit OK. And you notice that only one is reported. So we want to make sure that we add both. So we're going to keep 37 and we're going to add 41. So we're going to go 37 and also 41. All right, so those are the modes. And of course, for standard deviation, we will just go ahead and enter the standard deviation for a sample. Okay, and put our values in. And there we go. All right, good. So we have all of our measures of central tendency, and of course we have our standard deviation entered in. Let's go ahead and calculate our R value. So there's two different functions you can use for your R value, either Corel or Pearson. I'm going to go ahead and use the Pearson value. Okay, I'm going to use that function. So we're going to go to statistics, right? And we're going to scroll down. We're going to look for Pearson. And it is right there. Let's go ahead and select that. And it's going to ask us to put our two arrays in. All right. And if you take a look, it actually tells you, for example, array 1 is your independent values. This is your independent values. So we're going to go ahead and input our X values in here. Okay. So this is our independent. Okay. We're going to enter that in. And then for array 2, this is our dependent values. So we're going to go ahead and enter in our VO2 max because we're looking to see how body weight affects VO2 max. So in this example, this is the independent factor and this is the dependent factor. And we're going to enter that in. And we're going to get an R value of negative 0.856. All right, so that quickly, basically, you've already calculated your R value. And of course, you know from this value, just looking at this value, that it is a very strong relationship. Okay, this is a very strong relationship between body weight and VO2 max, and it is an inverse relationship or a negative relationship. So what that means, as one value is increasing, the other value is decreasing. Okay, as one increases, the other decreases. So as body weight increases, VO2 max is decreasing. Okay, so that's what that negative sign means, but that is a very strong correlation. We have a 0.856. All right, let's go ahead and figure out our coefficient of determination. So right down here. So two ways you can do this. You can either just go ahead and straight up square, okay, whatever value is in this cell, or you can use the function, okay, you can use the function under statistics, okay, RSQ, okay, RSQ. So that is going to give you the R squared. Okay, so that is your coefficient of determination. So let's go ahead and select that. And be very careful. Make sure you look at this input box. It's asking for the Y values first. If you put your X values in first, it could completely throw off this formula. So always double check and make sure you look to see what Excel is asking for. So in this example, it's asking for your Y values first. So let's put those in. All right, we're going to put our VO2 max scores in. And then we're going to put our X's, which is our body weight. So let's go ahead and put our X values in right here. And then we're going to hit OK. And then you can see our coefficient of determination is 0.733. So again, what does this mean? Basically, in a nutshell, what that means is turn this into a percentage. Okay, if we take that and turn it into a percentage, it's about 73%. So basically what this is saying is 73% of the variability in a person's VO2 max can be explained by the person's body weight. Okay, so 73% of a person's VO2 max, that variability, okay, is correlated with a person's body weight. All right, so there's some other factors that affect a person's VO2 max, but 73% of it, according to this data, 73% of it can be explained purely by how much the individual weighs. Okay, now of course our N value, we already calculated that. That was 10. And for this problem, the degrees of freedom are going to be n minus 2. Okay, so we have 10 sets of paired scores. So for these correlational problems, degrees of freedom are going to be n minus 2. So in this example, our degrees of freedom are going to be 8. All right, so let's go ahead and make sure we center that and make it nice and big. So, oh yeah, that's nice and big. We can see it. Okay. All right, now we are ready to look these values up on our chart of statistical significance to see if these values are statistically significant. All right, so let's go ahead and we'll move into that next. Okay, so here we can see our R values, and you can see the strength of a relationship based on your R value. So again, anything above a 0.8, anything above a 0.8 is a very strong relationship. From 0.6 to about 0.79, again, that's a strong relationship. So on our first problem, we had an R value of 0.856. So we have a very strong relationship between a person's body weight and VO2 max. All right, so is it statistically significant? All right, and basically what this is asking is how reliable is this R value? Okay, how reliable is this concerning the relationship between these two factors? So again, a question that this can answer is, if this study were repeated, what is the probability of obtaining a similar relationship between these two variables? Okay, is there truly a relationship between these two factors in question, or did this relationship purely occur by chance? Okay, was this a chance occurrence? Or again, does a relationship truly exist between these two factors? Right, so we're going to be looking at the number of paired scores. Again, if you have a high number of paired scores versus a lower number of paired scores, if you have a low number of paired scores, you're going to need a relatively high R value to prove that there really is a relationship between these two factors. Otherwise, again, it could happen purely by chance. Okay, so we're going to be determining our level of significance, or our confidence level. This is also known as our alpha level. Okay, at the 0.5 or the 0.1 level. So we need to determine which of these two levels we're going to be reporting. And of course, we need to determine our degrees of freedom. And for these types of problems, it's very simple. Degrees of freedom is just going to be n minus 2. Okay, n being the number of sets of scores minus 2. Okay, that'll be the degrees of freedom, right? So let's keep going. Now, these confidence levels, these are also known as alpha levels. And what did these mean? What does this mean, this 0.05, this 0.01? And 0.05 basically indicates that an occurrence would happen only 5 times out of 100 by chance. Okay, 95 times out of 100, this occurrence would happen because there really was a relationship between these two variables. Now, the way that I like to state that basically is that we are 95% certain that a relationship truly does exist between these two factors. So if you find that your R value is significant at the 0.05 level, that means we are 95% certain that a relationship truly does exist between these two factors, and that it did not occur purely by chance. Okay, now an alpha level of 0.01, that's indicating that we are 99% certain that a relationship truly exists between these two factors, rather than occurring merely by chance. So which is better? Which is a stronger level of confidence? The 0.01. Okay, the 0.01. 99% confident versus 95% confidence. So if you can validate your answer to the 0.1 level, then definitely you're going to want to validate your answer or your level of significance at the 0.01 level. Okay, that is indicating a 99% level of certainty. Okay, and how we're going to do this is we're going to calculate the R value, which we already did using Excel. We're going to determine the degrees of freedom, which is n minus 2, which we already did. And then we're going to go ahead and determine our level of significance, or our alpha level. We're going to start by looking at the 0.05 level, and then we're going to move over to the 0.01 level and determine whether or not our value was statistically significant. So here we are back with our problem, and over on the right you can see our values for the correlation coefficient. So you can see our columns. So our first column here, this is our degrees of freedom right here. So we already calculated our degrees of freedom. And then over here we're going to be looking at our alpha levels. Okay, so again we're going to be looking at 0.05 and 0.01. All right, so over here on our problem, we can see our R value is 0.856. Okay, our degrees of freedom, okay, right here, our degrees of freedom is 8. So right here in the chart, we're going to find degrees of freedom of 8. So that is going to be right here. So right here, we're going to circle that. Okay, so that's our degrees of freedom. All right, so we're going to be looking at that row. So let's take a look at this row right here. And is our R value higher? Okay, we're going to start here at the 0.05 level. Is it higher than 0.632? And it is. Okay, we ignore the sign right now. The sign is just telling us, is it a direct relationship or is it an inverse relationship? So right now we're just looking at the value. So 0.856 is definitely higher than 0.632. So now we're going to move over to an alpha level of 0.01. Right? So is our R value higher than 0.765? And it is. So what that is telling us is that there is a statistically significant relationship between these two factors, between body weight and VO2 max. And it is statistically significant at the 0.01 level. So that means we are 99% confident that a relationship truly does exist between body weight and VO2 max. And that's how you would state your conclusion for this problem. So to sum it all up, guys, before we move on to our prediction formula, is you would say, based on our R value, so right over here, based on our R value, that there is a very strong inverse relationship between body weight and VO2 max. And it is statistically significant at the 0.01 level. So that's how you would want to state your conclusions for this particular problem. You definitely need to state your R value. You're going to go ahead and state your coefficient of determination. And then, of course, you do want to state the nature of the relationship: strong, moderate, weak, inverse, direct, and is it statistically significant? If it is statistically significant, make sure that you note at what alpha level, the 0.05 level or the 0.01 level. All right, that's going to be part 1 of our correlation problems. For the next lecture, we're going to quickly talk about predictions and a little bit about linear regression, and we're going to show you how to do that using Excel. All right, everybody, I hope that was helpful. If you have any questions, please let me know. Otherwise, guys, I hope you have a great day. This is Mr. P, and I'll talk to you soon.